Okay, let's begin another mini-series. This is a continuation of our study of Haar Wavelets. We're going to go and start talking about two-dimensional Haar Wavelets, and start our study of two-dimensional Haar Wavelets with the study of square functions, basic square functions. So this will be our coordinate system. You can think of it as the standard coordinate system, where y is facing true north and x is facing east, rotated by 90 degrees. So the basic square step function is denoted by phi 0, 0. I will explain to you shortly what those superscripts and subscripts mean. Well, the subscripts is the coordinates of x and y coordinates, where that step function is defined. So it's defined to be 1 if x is greater than or equal to 0 but less than 1, and y is greater than or equal to 0 but less than 1, and it is defined to be 0 everywhere else. So it's a two-dimensional step function. So you can think of it as if you think about a two-dimensional plane, and this is our scale, third dimension. So in the third dimension, the value of this function goes from 0 to 1, and it is basically defined to be a 1 in this square that starts at 0, 0, right? So, and then it is defined to be 0 everywhere else, right? So it starts at 0, 0, goes from 0 to 1 on the y axis, and from 0 to 1 on the x-axis. So we have this cube, right? Okay, and it will be, so this is the y-axis, and this is the y, right? I wrote x, this is y. Y-axis goes from 0 to 1, and this is the x-axis, also goes from 0 to 1. So the step function is only 1 here, and 0 everywhere else on the plane. So the superscript defines the exponent of the power of the 2 in the denominator. So because it's 0, because our square is of size 1 by 1. So 1 divided by 2 to the 0th is 1. Okay. So let's define the 4 square step functions that can be derived in terms of our basic square step function. So the first one is phi of phi 1 0, 0, superscript 1, and then sub 0, 0 of x and y. I'll explain to you again shortly what the superscript 1 means. 0, 0 is simply where the square starts, and the superscript, well, you know, we can talk about it right now. The superscript means the power of 2 in the denominator, because the size of the basic square that this step function will be covering in the two-dimensional plane of x and y is going to be of size 1 over 2, half. So, and in terms of the basic function drawn above, phi of 0 sub 0, 0, it can be defined as follows: phi 0 sub 0, 0 of 2x and 2y. And it's equal to 1 if 2x less than or equal to 0, greater than or equal to 0, but strictly less than 1, and 2y greater than or equal to 0, less than 1, and 0 everywhere else. So if we do some algebra, then I'll figure out that this function phi1 sub 0, 0 x and y is going to be equal to 1 if x is greater than or equal to 0 and strictly less than 1, or just dividing by 2, and y is strictly less than half and greater than or equal to 0, and it's 0 everywhere else. So if we attempt to notice that we've just obtained this definition by plugging 2x and 2y in the definition of the basic step function drawn above, defined above, phi 0 sub 0, 0. Right? If you plug in 2x instead of x and 2y instead of y, that's what you get. So here is a sketch of this function, what this function looks like in 3D. So this is our two-dimensional plane. So notice that the square is of the size half and half, 1/2 and 1/2. So that's what the superscript means. So, and it is this square 0, 0 means that, okay, this is where the top left, right, of that square, the top left corner of the square covered by this step function is at 0, 0. It's at 0, 0. So that's what we gonna have. We're gonna have again this cube. Again, it will look like this. So it's 1 so long as x and y are in that within from 0 to half, and 0 everywhere else. And this is the superscript is the power of 2 in the denominator, because the size of the square is 1/2 by 1/2. Okay. Okay, so this is the first of the 4 square step functions. The second, okay, we're just gonna go clockwise on the two-dimensional plane, and the origin of this square step function is at 0, 1. So it's phi1 sub 0, 1 of x and y. Again, we can obtain it from the basic square step function by plugging into x instead of x and to y minus 1 instead of y in the above definition, right to the right of the coordinate system. So, and let's do some algebra. So it's it is 1 if 2x is greater than or equal to 0 and strictly less than 1, and 2y minus 1 is greater than or equal to 0 and strictly less than 1, and it'll be 0 everywhere else. Okay, so and again, so that comes out to be 1 if, okay, let's divide by 2 if x is going to be greater than or equal to 0 and strictly less than half, 1/2, and okay, so y will be greater than or equal to 1/2 and strictly less than 1. So if we add 1 to both sides of that inequality, and 0 everywhere else. So if we let's draw a sketch of this step function, it'll be okay, this is our 2D plane, slightly rotated just for a better presentation. 0, 0, this is half on the x-axis, this is half on the y-axis, and the origin starts at 0, 1, so the origin of this function, that's right here. So we're gonna, okay, this is half, and on the x side, and this is half on the y side. All right, so this will be our cube, right, in 3D representing this function. So the value of that step function is 1 so long as x and y are as shown in the drawing and as defined in the definition, it'll be 0 everywhere else on the xy plane. Okay, just putting final touches. Right, yeah, just making sure that x is strictly less than half and y is strictly less than 1. Okay, so then again, going counterclockwise in our 2D plane, let's do 1, 1. Phi, the basic function, phi 1 sub 1, 1 starts at 1, 1. X is defined again in terms of the basic square step function as phi of 0 sub 0, 0 to x minus 1 to y minus 1, scaling the basic function. And this comes out to be 1 if 2x minus 1 strictly less than 1 and greater than or equal to 0, and 2y minus 1 is greater than or equal to 0 and strictly less than 1, and 0 otherwise everywhere else. Okay, let's do some algebra and get rid of minus 1 and 2. So inequalities. So it is going to be 1 if x is going to be greater than or equal to 1 over 2, half, and strictly less than 1. And y is going to be, so adding 1 and dividing by 2, greater than or equal to half, 1 over 2 and strictly less than 1. So, and it'll be 0 everywhere else. So let's draw the sketch this step function, square step function. So our square is going to be again half, because the superscript of phi is equal to 1. So in the two-dimensional space, two-dimensional plane, the size of the square covered by this basic square step function is half by half, right? And this is our square. So when x and y are in this square, then the value of this step function is going to be 1, be equal to 1, and it will be 0 everywhere else on the plane. Okay. So this is f11, phi 1, 1. Okay, and this is the fourth of the four basic square step functions. And again, the superscript is 1, because the basic square is going to be half by half, and it starts at 1, 0. Okay, and in terms of the basic square step function, it's defined as phi 0 sub 0, 0 of 2x minus 1 and 2y. And if we, let's do the derivation, it's 1 if 2x minus 1 is greater than or equal to 0 and less than 1, and 2y greater than or equal to 0 and less than, strictly less than 1, and 0 everywhere else. So a little algebra: 1 if if x is strictly less than 1, greater than or equal to 1 over 2, and y greater than or equal to 0 and less than 1 over 2, and 0 everywhere else. So let's see, I have some space left here, so let me quickly sketch this a step function, basic step function. So it will look like this. We'll compare these 4 step functions, look at them side by side in a couple of minutes later, a couple of minutes later into this screencast. Okay, so let's take a look at them, 4 square step functions side by side, what they look like. So so this is our phi 1 sub 1 1. Let me just draw the ribs of this cube with green, and so this is phi 1 sub 1 0. Okay, and this is phi 1 sub 0 0. Okay, and yep, and this is phi 1 sub 0 1, right, for basic square, so basic step functions. Okay, so here's an example. Let's do a quick example of how we can use those basic 4 step functions to approximate a function. So let's say that we have the function whose value at 0 0 is 10. F of 0 0 and half is equal to 8, and f at 1/2 and 0 is equal to 5. Well, let's do 5. Yes, okay. And finally, f at 1/2 and 1/2 is equal to 4. Let's do 4. Okay. So this is our scale. I did the 3rd dimension. So this is 4. And this is 5, and 6, 7, 8. Okay, this is 8. Okay, let's draw 2D square. Okay. All right. Okay, so this at 0 0 will be 10. Well, I need to okay, this will be, I need to erase this because I'm drawing in 3D. Okay, this will be 10. Okay, so on this square, it'll be 10. So the cube will look like this. Use an orange. Okay. Then f of, so that's the origin, right? 0 0. So f of 0 and half is equal to 8. So this is green. So this will be, the cube will have the height of 8. Okay. Will look like this. All right. And then we have at 1/2 and 1, so x is equal to 1/2 and y is equal to 0, 1/2 and 0, right? F of 1 over 2 and 0 is equal to 5, so this is this cube is going to have height of 5. Okay. Okay, and at on the origin 1/2 and 1/2, f is gonna have the height of 4, right? Well, rather the approximation, right? We're approximating with cubes. Okay, so that's what it looks like. Our approximation, and so from this, like pink, right? This is the pink cube. So the approximation f of tilde, just basically the same notation as as the one that we used in the one-dimensional space, is going to be equal 10 times phi 0, 0, 1. And this is okay, so 10 times phi, and this will be this cube, okay, plus 8 well, it doesn't really matter whether we go counterclockwise or clockwise, but let's just do go clockwise. F phi of phi 1 sub 0, 1, 8 times phi 1 sub 0, 1. This will be this green cube plus 5 times phi 1 sub 1, 0. This will be that blue cube plus, we need to add the pink cube 4 times phi 1 sub 1, 1. And this is the pink cube. Okay, this is to be continued. Thank you.